Hello everyone. So today what we're going to talk about is the project Sneaky Sneaky. So this is going to be a culmination of everything that we've been setting up and building up to, and we're going to put it to an actual practical use of a actual project. This will actually have you work through and also implement some certain features on your own beyond just using everything we've been shown before. They are all based off things we've been showing before. So like Project Sneaky Sneaky, you can start off with any experiment that you previously worked on and just build off that so you don't have to build everything from scratch again. There's this tutorial here that we'll actually walk through in this live session today about how to get the player click to navigate working. Then there's additional resources just in case. Down here in the instructions, it basically tells you how it wants the layout of the level, some primitive shapes. Keep that in mind. We do not want you using ProBuilder to build out the levels. It should just be primitive shapes. And a terrain for the ground. And plenty of space for the guards to walk through. There should be 4 distinct rooms. So keep that in mind. The main thing we're looking for, we're not looking for anything fancy in terms of level layout or anything like that. It can be very simple rooms, and I have the other example project right here, just like this, where it's got 4 very clearly separated areas that the player can go through. Does not have to be set up like this whatsoever. You can lay out the rooms however you want, just as long as there are 4 distinct areas that those agents in the room tend to just go through the nav points in that area. So, taking a look back at the document, this one will actually be you're turning in an entire project. We'll talk about that towards the end of the lecture when we actually have some more stuff working. As far as the implementation goes, you will need some sort of manager. So it needs to be on a game object script. So we just had the nav agents with a manager just before this. You can use that as your foundation. And as in terms of like renaming it to guard manager, I am not a stickler for names like that. I'm more a stickler for making sure that the functionality is there. So if you leave it just as agent manager, I'm perfectly fine with that. Same as like renaming the nav agents themselves to guards. I don't really care what you call them as long as it's clearly functional. Then it talks about the inputs, so left and right arrow keys to navigate back and forth, select one of the guards, and it should show the active guard, the one that you've got selected, as yellow on the highlight, or if you followed along with the previous lecture, I'm perfectly fine with the light being there as well, just to make it a little bit more interesting than a cylinder turning yellow. Next up, we have some key codes. You should already have pressing the 1 key to actually pause on that. The 2 key will actually be a new feature that you're going to have to implement, and it should actually tell the guards to reverse the order that they're going through those different nav points. So, for example, if our agents, if we watch this right now, if our agent goes to that nav point first, then that nav point second, while he's traversing, I should be able to press 2 and stop his traversal and make him go back to the previous point and then go through them in a backwards order. An example of seeing that in game, we can play this example Sneaky Sneaky I have right here. So we should be able to click to actually move around our character. So our character is this capsule here, and we'll walk through how to get that movement working. And we see it is actually navigating around when I click on either side of the walls. We then can press the right key to select one of the guards. We've got that one selected right now. If I press 1, it should pause that agent. If I press 1 again, unpause. So that's basically the stuff that we've had from the previous one. If I press 2, should change colors, indicating that it's in a different state or behavior. And we see it's actually going to reverse its direction of way it's going. If I reverse it back, should go back to the one it was just at, stuff like that. We then have a third key press, and this one, if we let him get around there, if I press 3, we see he's in a red state, and the red state is an alarmed state. So each one of the rooms will have what is called an alarm node. And the alarm node can be represented by anything you want in the level, even if it's just like a red cube or something, just somewhere that we can visually see where that node's at. And it should act similar as a separate nav point. But when we press that 3 button, and sorry, let me get that out of the way. If we press, oh, and I didn't mean to click up there. Come on, that's the other feature. If I press 3, we see it's going to what is called like an alarmed state, or angry state, and it goes over to that alarm. Think of this as a distraction technique. Like if you ever played Assassin's Creed or something like that, you can throw a rock at a wall or something, or coins and stuff, and it'll distract guards. So think of that kind of like that feature. If we press 3 again, obviously we just have it through certain key presses to set the alarm off. I like to think of it as our player has some sort of remote hacking, and he remote hacks a terminal to set off an alarm. The guard goes to investigate. And when the guard actually investigates and hits that, I would recommend just switching them back to idle. This one's not currently doing that, but would just be something to look out for in the future if you wanted to go to the alarm, then after it's investigated, go back, more game-like. So 1, 2, and 3, 1 is pause, 2 is reverse, 3 is that distraction node. So they have separate behaviors that we can just issue commands from, only to one guard at a time, as you saw. Back to this one. So this one's just describing the different key presses. Then down here is actually describing the colors that the guards need to be set to indicate what state they're currently in. So patrol is green, idle is dark green, that was already set up for you. Pause is gray, that's also just from the previous experiment. Angry should be red, that's going towards the alarm. Pursue should be magenta. So we haven't talked about pursue too much. It did happen a minute ago when I accidentally clicked, but let's take a look at that. So our guards, the goal of this game is to avoid the guards and try and get to the end area or something, navigate through the entire level and escape from your prison. That's one of the reasons why they're called guards. So if we start navigating through, and I don't want to aggro the fast one, I'll aggro this one. So if we actually get near a guard, close enough to it, it's going to pull aggro, and rather than that guard just following along with its path, it's going to be starting to chase the character. Now, you can see this situation right here where my guard is just as fast as my player, so I'm not going to be able to get away. I'm not sure if we talked about it before, but I will mention how that works. In our guards, each individual guard can have their own speed set. That's right in the nav mesh agent component. You can actually change its speed. Let's say that one's going to go 8. That was the faster one. This one was only going 3.5, so we got away from it pretty quick. But you can change that to whatever you like to create a more interesting feel for your game. One big thing that I would recommend is trying to balance it a little bit. I'm not going to worry about that too much, but if all your guards immediately aggro and have like a sight range that's huge, that they pull aggro all the way over from the other side of the level and are immediately chasing you the same speed, you might want to consider balancing that out a little bit. So if we transition to our next room, and oh my gosh, I forgot I turned all those off. Dang it. Turn that back on. As far as the camera goes, that's actually a good point to transition. The camera is completely up to you. The way this one's set up, there's a couple of different setups we'll look through in a few moments, but this one's going to have trigger volumes that when the character actually hits a certain trigger volume, it's going to move the camera to another position. We can see that trigger volume right here. When the player hit it, it moved the camera over so that we keep that player in view. There's a lot of different camera setups that you could have, whether it's directly attached to the character and moving that way, or for example, this way where you have trigger volumes and it only transitions when you hit the edge of the room. Either is perfectly acceptable. So that's really just designer's choice there. And as I mentioned, the goal of the game is to get to the end. And when you hit that end trigger volume, it should display you escaped. So the way that one's working is just when the player enters that trigger, it turns on a canvas element to actually show the text you escaped. So that's about it for the game itself. The document describes what each feature should be doing. And this one will be turning in the entire assignment, not just taking a screenshot like the previous ones. So if we take a look at that, there is a feature sheet also associated with this. So we'll open that up. And you're going to want to actually download this and download it with whatever account. Then you can open that up. Oh my God. Can't click today. It's been a long morning so far. There we go. All right. You're going to want to enable editing, and then I would recommend filling this out alongside while you're actually working. Once you create the different items, making sure that the actual scene is named correctly, go ahead and add an X for marking it complete. And we'll see it gets that score added. And as you add each one of the features, just go ahead and add an X here. If you do have something specific that you want to point out while I'm grading this, I will look at any comments you add in here. So for example, like if you have a path node, we can call that nav point instead. Since I believe in here, each one of the path nodes is called a nav point instead. So just look out for those and specify here in this explanation section of anything that you might want me to look into, or something. For example, if you get the reverse kind of working, but it only goes back one node and then switches to normal patrol, then make a note of that in here and I can help explain that further while I'm grading. Same as if you choose like a different highlight. If you did the lecture version where you do have a light, make sure to specify that here in the notes, and be sure to mark any features that you have finished as complete. So then when I download your project, I will also be downloading this. So this also has to be submitted in the zip that you submit. And I'll be grading based off of this rubric here. All right. So back here, that's about it for the actual explanation of the assignment itself. But before we go today, I want to actually show you a couple of things from our previous project, which is this one. So this is the project that we created on Monday. And this is the nav agents with a manager. We play, we can select the different agents using the right or left arrow keys, and we can pause an agent by pressing that one. So this is a great foundation to get started for the rest of the assignments. So if I wanted to add, let's say, another level in here, one thing I would recommend doing is creating an empty object to store each level in, or area. Area and area 1. We can then put anything from that level into that area. So we have that all nice and wrapped up in one complete section. We could create a new terrain if we wanted to and duplicate everything in this level. I would recommend keeping just one directional light outside of the levels, geometry and stuff. But really how you lay out the folder hierarchy or the scene hierarchy is up to you. One big thing I do want to point out is that you could have multiple agent managers if you wanted. So if we did duplicate this level or this area, and we were to move that over there, kind of towards the edge, and we take a look at this. I don't want to have a second camera. So the camera, we'll leave that. And of course, internet's going out. All right, so we've got these two levels. I want to make sure that they are touching over here. Big thing to remember is when you actually create this, you want to make sure that any level geometry you change, you're going to rebuild the navigation. We see right now our navigation only goes right there. So if we try and play, we'll see these guards are all working, except that top one, because he's actually from the other level, can't actually get over to those nav points. So we want to make sure to rebake our nav mesh. Now with it full, if we play, we can see our agents are all moving around. Okay. So we've got two areas set up. I'm going to rename this one so it's not just area 1, area 2. And if we take a look at how our input works now, we're actually selecting just this one agent again. If we tell it to pause, we see it's only pausing that one. If we try and select the other agents, we see that one is actually selecting agents from the other one as well. So if you do have multiple managers, they will all just be dealing with their rooms at a time. So we can actually select multiple. Just wanted to show that, how that would work if you do have two agent managers. It does keep it kind of nice since each agent manager only focuses on the ones that are in its room. So the other part of this, let's go ahead and create a player character that we can have move around through this room. So we'll create it outside of everything else. Add a new object. We'll go with a capsule. And go to the inspector. Try and center its position. And I don't have 0, 0 as the center. We'll put it in the middle. We see this guy's really tiny compared to the other ones, so we do want to scale him up. Let's go by a factor of 3. Oops, not 33. And actually 3 is pretty big. We'll just go 2. All right, so we've got a character placed in the world. And I think right now it's halfway down in there. Pull it out of the ground just so it's not colliding with it. 1.75 is exact. Then we need to add a few things for this. We want this to be able to navigate. So we can go ahead and add a component. And we'll add that nav mesh agent. Change its settings down here, how fast it'll turn, how fast it'll actually move, how quickly it accelerates. Let's say it's going to move, I like 7. We'll go with that just as a start. And we got to get a script on this to start navigating around. So we'll add this, we'll do a new script. We'll just call this player. Keep it pretty simple. And let Unity catch up. And we'll open that up and take a look at how we can get it to move where we click. So I want this one to be using the navigation system. So I'll make sure to let the script know that I will be using Unity Engine.ai. Then as far as our class goes, first thing I want to do is get a reference to our nav mesh agent. And we'll call this nav for short, initialize it to null. Then in start, we can ask our game object for that component. And the type of component, that's a nav mesh agent. And we can set that variable we created to the return value of that. So now that we have our nav agent, we can tell it to do things and update. So I want it to move when I click. First thing we'll need to do is check if I've clicked. So we'll get key down, key code dot mouse 0 is the left button. When we click, we're going to need to find out where we clicked in the world. So there's a few different ways to do that. I believe through the camera, there's some useful functions. We'll just ask for the main camera. And I think it's screen point to ray. We'll go with that. We got to pass in where our mouse is at. Let's ask our input system for that. And this returns a ray for us. What we can do with that ray is send that into a raycast. So we'll catch the return of that. Ray R is going to be that converted mouse position. And then we'll ask our physics to do a raycast. There's a lot of different overloads. A few things that we could specify if we have different layers and only want it to focus when it hits the ground and things like that. But we'll just use a simple one, but we want that information about what it hit as that output. So it looks like number 8 will be the best one. We have to give it a initial position and a direction, or we could even do, there's a few others. First thing we'll do is just pass in the ray. And let's see, there's a lot of different ones, and I'm just want to choose one that I haven't really used too often so that we can see something different. And we'll just go with, yeah, that's going to be the best. So we want the origin of the ray, the direction of the ray, and we need a variable to fill out since this is an output parameter. So that's actually specified by this out keyword right here. This is similar to a return. So this function returns a bool, but it also will fill out a raycast hit structure if you pass a variable in. So we're going to need that variable to pass in. Raycast hit. We'll just call it hit. We'll pass that in as our output parameter. And can't forget to add the out keyword. And this is going to complain because it's returning a bool and we don't have anything using it. So we're going to want to check if this raycast did hit anything. So if it did, our hit variable gets filled out. We can then ask our hit variable for its position. And what we want to use that position for is, well, we're going to tell our navigation nav mesh agent to actually move there. So let's just do nav dot set destination, and we'll just say out is going to be the hit point. So the point that that ray detected a collision, whether we clicked on the ground or on a wall or somewhere in the level, it's going to try and navigate to that position. We'll save this, and we can check this out in game now. So if we play and we move around, we see it is actually clicking. Well, I'm clicking around the level, sorry, periodically, and it will navigate to those different positions. All right. So one thing I want to change about this is right now, if we do hit any of these triggers or anything, like if I wanted to see my player hitting this this nav point right here, and we go to our player script and we try to handle what happens when void on trigger enter. We'll go ahead and print debug log. Player hit something. Save that. If we try and see if this is going to print, our output log is going to be quite cluttered with everything printing from the different navigation stuff, what it's doing and everything. So I know I showed it before, but I do want to show that again. If we want to get rid of just all the debug printing and make like we're looking for specifically, did it print when it hit one of these, we can silence the state machine a bit. I don't know if I've mentioned this before, the inconsistent line endings. So this won't have any effect as long as you're working on the same computer, but if you are working with some people on Macs, some people on Linux or something like that, you do have to actually communicate with your team which line endings you're going to use. Since I'm on my own computer and I won't be sharing this project with anybody, it doesn't matter what line endings I use. But that can have some interesting behaviors. If someone's on a Mac, they submit something and then you're on Windows and you get it and it will literally have Japanese characters and things like that because it doesn't detect lines were ended and screws up all the text. So in here, we'll take a look at our state machine. And I believe it's in, I want to say state. Yes, cool. So right here inside the state, there's a little comment saying comment to silence. What this does is turn off all of the extra logs for what state changes happen, when states are initialized, things like that. So once you have your state machine working properly and all the transitions are correct, go ahead and comment that out so that you can just see the prints that you want. And if we try and watch this again, we'll see if our character, so it just ran through a trigger and it did not cause a trigger. It didn't print anything. Our player should be hitting this when it enters a trigger. So this has to do with what object types are being compared with other object types. Since our character itself is just got a capsule collider on it and it was hitting another collider, that doesn't generate those collision messages. You would have to add a rigid body. So if we add a rigid body, one thing we're going to want to make sure we do is check this is kinematic box. Because if we don't, well, we'll actually take a look in a moment. If we start moving around and like try and go up here and like hit other objects and things, our navigation system will get kind of screwed up and the physics and navigation will be fighting each other. So one thing you typically want to do is say, since the navigation one is controlling this, we want it to be kinematic. And we do see that when it crossed through, we are getting that message now. So that's always something to look out for if you're not getting that print message for when you enter that game over trigger. Make sure you do have a rigid body on your character. So we got our player moving around. We can select the different ones and just issue them the pause. But we'll want to make sure, let's take a look at our next step of getting our camera. So for example, if my character runs way up here, I can't even go to that second area I've created because our camera right now is just sitting where it's at. So as I mentioned, we could set up a trigger so that when our player enters that trigger, it sets the camera position to something that would show that second level. Or we can do a couple other things. The easiest way to do this, and before I forget, I left my player named as Capsule. Oh, it's awful. Player should be named Player. I'm gonna just move him out of the area stuff so that he's right up here with the other basics. If we actually attach our camera to our player, our camera will move along, but it will also rotate with our character. And that can be quite disorienting, depending on like if you click opposite directions and things like that, with all that rotating around and stuff like that. So that is a quick and dirty way of getting that working. But if I wanted to detach that, we could have some sort of script that just follows our player. So our camera, we could add a script. So let's take a look at what we could do for our scripts. And we'll just call this camera script. There's a lot of different ways we could set this up. One of the easiest ways to do it would be to get an actual reference to our player game object. So let's get a variable of type game object. We'll just call it geo. And we'll initialize this to null. Then in start, we could actually find our player. We could say geo is going to be equal to find object of type. And since we only have one player, we could just search for that player type. And cannot convert from player to Unity. So we'll make sure that it gets the game object of that script, not just the script itself. Then in our update, we could go ahead and set its position or rotation. Let's just do set position. And that's in the transform. Transform position equals, and we don't want to just say equals our player's position. Because that would shove the camera to the ground and actually causes some issues. So if we play this, we'll see our camera gets shoved to our player's position right there in the center of our character. We can click around, but that's not very usable. So what we could do is change a few different options. If we only want the X and Y or X and Z positions of our character, we could say this is, instead of just setting it directly, we'll create a new vector. Come on. New vector 3. And for our X position, we do want it to go to the transform. Transform position X. And we also want to, we don't want to set the Y since that's the vertical of this. So we'll just use our current Y from our transform. But we still also want our player Z. Transform.position.Z. And new vector 3 is going to complain. Interesting. Oh, I don't know where system numerics got added in. Okay, don't know what that was about. I might have accidentally hit enter on vector and then it just added it for me or something, but it's supposed to be vector 3 from Unity. There we go. Save that. And we can now check this out, and it should keep the Y position the same, but allow us to click around without changing our rotation. All right. So we've got our simple camera set up. We've got our agents being able to select and issue them commands. The one other thing I wanted to cover today is also how to actually aggro our agents or actually issue them commands based off of not just an input press. Because this one works a little bit different where if we actually get close enough, it'll switch the state. All of our other states are based off key presses or collisions when it hits the nav point. So we'll take a look at how to do that. There's a bunch of different ways how you could have that set up. Whether you put some sort of collision radius on each of the enemies or something like that for them to detect when a player enters that trigger. The way I like to do it is keep it even simpler and just put a collision radius on our player itself that is like going to be like it's emitting a sound in this big of an area. So if you're within that area, I want to alert you that you should change your state. So we'll be on our player, and we could keep this as a separate script. We could add a new script for this, and we'll just simply call this aggro. So our aggro script will need to do a couple of things, and I already kind of mucked that up because I didn't want to put it directly on our player. I was going to make a child object, but let's actually do that now because I was talking about a radius around here. what we need is a radius for that. So we'll go to create a new empty object. And this empty object, only thing we'll add to it is a sphere collider. We want this collider to be a trigger. We don't want some huge ball rolling around like that. And we can specify what radius we want. Let's go 10's huge radius. Definitely don't want it to be that big. 5, that's pretty large. Not 54, 4. Yeah, that's fine. So we've got this radius around our character that's set as a trigger. And we'll add our script here rather than on our trigger. So aggro will get added here. I don't want it on our player. And we'll even rename this game object to aggro radius. So now we can go to our script, and that's attached to just this aggro radius. So our script, we don't care about start or update. The only thing this will care about is when a guard or agent enters it or exits it. So we only need to handle on trigger enter, and we'll also handle what happens when they leave that area. So on trigger exit. On trigger enter, we're passed in that other collider that's hitting us. Well, we can ask that other collider and say if other has a certain component, and if that other component type we'll be looking for is our actual agent script, which is nav agent state machine best, which is a mouthful. I would kind of recommend renaming that. I'll just keep it the same since you might be used to how that's set up right there. If it does have that, we could then communicate to that script. So rather than doing another other get component again to just start talking to the script, I'm going to store this in a variable. So before we even do the if check, I'm going to get a reference to this. So nav agent state machine underscore best, and I forgot to capitalize M. And we'll call this other agent. We can then check if this was not null, because it will just return null if the other thing you're hitting doesn't have this component. So if other agent is not equal to null, we can then go ahead and use it. We can tell that other agent to do certain things. As far as what it should do, it should be switching to a pursue state. That state you're going to have to set up on your own using the knowledge that we've put together already. What I'm going to have this one just do as an example of how to communicate that, I'm going to have it pause the other agent. So other agent pause. So when it enters, should pause that agent. We'll work on this one after we test this out. So if we play, and let's try and pause this agent. So once we got close enough to it and it got within the range, we see it did actually pause that agent. If we let it leave and we get another enter again, it'll unpause. So a couple of things with that. We need to make sure that it just unpauses as soon as it leaves. So we're going to do the same exact thing for when it exits. Since pause is working as a toggle, first time it hits, it'll turn pause on. Second time it hits, turns pause off. So we basically created Clefairy singing. So it's going to pause anytime one of the agents actually gets close enough, and unpause anytime one of the agents gets far enough away. So that's just a quick way of how you can communicate back and forth between those scripts. And other than that, that's about it for this assignment. The rest is actually just creating the level layout and stuff like that. So you should have everything you need for finishing this up. Are there any other questions or anything like that before I go ahead and stop the recording? All right, so I'm going to go ahead and stop the recording then.